First thing I'll say is that this is a repost. I gave this talk in January at the MongoDB LA conference. I think I saw some of you guys there, so apologize for the repeat. But that was 6 months ago, and a lot's happened on our platform since then. So I'm going to talk a little bit about where we were in January and where we are now. So if in case you don't know what the knot is, yes, I heard somebody say that it's a play on tying the knot. So it's weddings, newlyweds, babies, and style. It's our company changed names a couple of years ago from the Knot to XO Group to reflect all of our brands: the Knot, the Nest, the Bump, WeddingChannel, Gift Registry 360. We are headquartered in New York. We have offices in New York, Austin, Texas, LA, and smaller offices in Omaha, Reading, and Guangzhou, China. So we have over 150 developers worldwide, and our traffic is something like 11 million unique visitors per month, 300 million page views a month. The one thing that's unique about us is that we actually serve a niche. So we serve these different markets, and we do web software and mobile software for anything that niche and that market needs. So articles in CMS, we have a lot of photo gallery software, we have membership favorites, community forums, planning tools, a local directory of all the wedding vendors and baby vendors. We have gift registry software, which I designed, and we have e-commerce software as well. So I took out a slide, which I guess I shouldn't have, but I'm Jason Sirota. I'm the director of software architecture, so I'm actually responsible for all of the software architecture throughout the company for all of these products, which means that I stay at an extremely high level most of the time. You could talk to me about algorithm optimization, but I would probably lose you at round two. But I do a lot with message bus and message-oriented architecture, a lot of data, NoSQL stuff, and things like that. So that's really what I'm going to talk about today. So the way that our company-wide architecture works is that we're, what I like to joke of, is sharded by business line, which means that every business line throughout our company has their own, essentially, business logic and database tier that they maintain themselves. For a long time, different business lines actually talked to each other's databases using connection strings. We have, in the last probably 2 or 3 years ago now, have completely implemented an API platform, generally on REST, which allows the different business lines UIs to retrieve data from cross business lines. So the next sort of phase of our evolution is to try to get from sort of Microsoft and a .NET stack that's N-tier architecture and by business line to a stack that's much more platform and API driven with a large number of open source platforms underneath. We still have a lot of .NET, we still have a lot of SQL Server, but we're obviously expanding into MongoDB. We have some Neo4j stuff. We have a lot of Solr and some Hadoop going on. And then on the front end, on the consumer side, we have still a lot of .NET, but we now are adding Python, a lot of jQuery and JavaScript, HTML5, iOS, Android, a lot of WordPress, and some PHP. So we are a truly polyglot shop. I was talking to some people, and since January, we're actually building a Ruby on Rails team in New York. So we're adding that to the diagram too. All right, so when we started to look at NoSQL services, what we really started to look at was schemaless design, right? What we were really interested in is document-oriented stores and trying to move away from sort of the RDMS architecture. And so we evaluated a number of different technologies. RavenDB was one of the first ones we tried, which was, you have a question now?
You said you're trying to move from RDBMS. Was there a prime reason for that?
I'll talk about that in a little while, but I will say that it sort of It has to do with our attribution store. So we have a lot of photo galleries which have a lot of sort of free text attribution. And rather than creating sort of an attribute value table that's part of our RDBM store, we wanted to move to sort of a document-oriented structure there. And we actually faced some challenges in that move, and we've sort of walked that back a little bit since January. So I'm going to talk about that a little bit later in the presentation. So C# was great, but and obviously it worked well with our C# apps, but it was limited to .NET. It was very new to the NoSQL landscape at that time, and we wanted something that was a little bit more established. Couchbase 2.0 was really a high contender. We were very familiar with Couchbase. We used them as our Memcached store, and our ops team was very comfortable with them. But unfortunately, when we had to do this project, it was still in beta, and we wanted something that, again, had enterprise-level support. So we ended up going with MongoDB, which had a very high user base, great community, and great client libraries for, obviously, all the platforms that we used. OK, so the first app that we sort of put into this sort of new idea for architecture, new open source development platform, was our search app. And the search app was essentially migrated from Google Custom Search, which, as you guys probably know or don't know, is just a hosted version of Google. It's limited to your site, and it's all text-based. So it looks like Google, it acts like Google, has ads like Google, and it's not a very pretty design. It wasn't something that we really wanted to continue with. What we wanted to get to was a very sort of Pinteresty looking photo gallery, very high quality, high image, grid view, and try to get away from the text-based searching. But the problems that we have is that, like I mentioned earlier, because we're really sharded across all these different databases, we had to try to ingest all of this data. So data from our gown storage database, data from our different products like rings and accessories and things like that, photos, photo galleries from people's actual weddings. We have a lot of that. Local directory, articles, blogs, e-commerce, etc. We wanted to get it all down into MongoDB and Solr, and then when somebody searched for something, we actually showed that thing. Okay. Yeah. So in order to get there, we could have done a couple of things, right? We could have done a pull architecture where on the search application, it actually made individual queries to each of those APIs, somehow figured out how to mesh them together, and then put them on the search results page. That would have been okay, but it probably wouldn't have gotten us to where we wanted to go from a performance level. We would have probably had to make at least 9 or 10 different service calls at that point, and meshing them together in some kind of logical order would have been nearly impossible. So, oops, sorry about that. So instead, we really wanted to get to a message-oriented real-time publishing system. And what we did was, in our individual source systems, they're running in .NET, so we actually layered on Microsoft Message Queue. We had those piped to a central server in our data center, and then we have this sort of job relay running where it listens to that MSM queue and then relays the message into SNS and then stores it in a queue on AWS. It's a pub-sub architecture, so there's 2 listeners. There's a Solr persister, which actually does the indexing, and then there's a MongoDB persister, which consolidates all of this entity documents into this MongoDB store. And that MongoDB persister and the Solr persister work independently. So they actually listen to the same messages. So at the end of the day, we are going to have all of our data sort of queryable in MongoDB in a deterministic fashion, and then also queryable in Solr from a free text fashion. And then we have a search API on top of it that's built into Elastic Beanstalk. Okay. So for our message format, we actually developed a standard message format and had each of the individual teams format their objects as different as they were into a format that was somewhat uniform for our company. And we had a lot of arguments internally as an engineering team about what we should actually put in this message. So what we ended up with was some basic information that we thought every entity should have, a collection of images there, categories, tags, and facets. Those have different meanings within our organization, which if you guys want to know what they are, I'll talk about them a little later. And then the compromise was that we would have an attribute section. So there would be a sort of free form JSON section that you could sort of stuff anything into as an attributes layer later on. There was a big argument about that, right? So there were a lot of people who felt that if we were going to do that, then it wasn't structured enough for people who were used to an RDBMS environment. And then the other engineers on the Mongo side were like, no, we need that because otherwise we're not taking advantage of Mongo here, right? Like there's no schemalessness to it. So we ended up with the attributes and we stuffed it all in there, right? Okay. So the Mongo persister was interesting. We actually utilized the static C# language pretty well here. And for those of you who are not familiar with C#, it's similar to Java in that you have, it's a statically defined language and you have inheritance and interfaces and so forth, right? So we had an entity inheritance and you actually configured the mapper, the Mongo mapper based on the class, the persistence class. So based on the C# class that you were using, you configured which Mongo database and which collection that it would go into. So this is very dynamic for us. We actually put our configuration all like this. So it's kind of like a convention over configuration model where we actually, based on the entity that you're doing, is where you're configuring that data to go into. Okay. On the document structure, we have. So what I wanted to show here, which is a little bit hard to see from this screenshot, is that we have a profile is one type of entity, and then the images that you saw in the collection a few slides ago, these images in the middle there, are actually in a different collection. And that was so that we could query the image collection independently of the parent object, so that you could query the image collection, get that nice, beautiful Pinterest flow, but without sort of reflecting all of the metadata that went along with it. Now, this turned out to be a pre-optimization for us because what we found was that you almost never needed to generate that Pinterest flow from Mongo. You always brought it from Solr because all of the image data was actually already in Solr. And that when we were going back to Mongo, what we were really interested in was the metadata. And so we actually separated this in a way that was probably too separate. Okay. The search API was pretty simple. You specified skip and count, the query that you're going through, and things like that. Okay, so here were some of the challenges that we faced. So one of them was UUID endianness. So the C# client had a big endian, and the Python Mongo client had little endian. And so when you went back and forth between Python and C#, it gave you a different ID value. And so we didn't like that very much, and we had to sort of write some custom code to be endianness aware, which is kind of annoying. And then the second thing was some weird stuff happened in the C# driver where we couldn't find MongoDB, but there was no other reason that we found that. So probably that's fixed by now. This is 6 months ago. I'm sure this is over. Other than this, we've had very little challenges with MongoDB itself. Like MongoDB has been extremely stable for us. And once we got to the replica set, and based on the usage that we had, we almost never have outages or anything with Mongo, right? But we have different problems, and I'm going to get to those in a second. I'm not going to go through a demo now, just to save time. Our Mongo instances, so we have one replica set. We have 5 instances over 3 availability zones in AWS. That's 20 total EBS volumes, elastic block storage. We use 250 IOPS for volume, and then we used to use EBS snapshot backups and an S3 data dump.
The snapshots you do on an individual basis, or you just do off primary? Or?
I don't know the answer to that. I will, if you email me, I will get back to you. So this is a slide that our ops team put together that I was not involved in. Yeah. Okay, so queries per minute. So we tested up to 6,000 queries per minute. We had a really great testing traffic. The performance was fantastic, both on the Solar and on the Mongo side. Our actual traffic was good, but I kind of faked the graph a little bit, right? Because these tests look very similar. You know, here's our traffic, but the y-axis was not similar. So this is what we tested up to almost 8,000 queries per minute, and this is what we got when we launched. So it looks like we way over-tested our capacity here. So since then, you know, we were happy that we did really good load testing, right? But we probably overspent time doing load testing, although we were pretty confident that we were going to be good when we launched. So what happened since January? So this is kind of the update. I looked at this presentation in this week before I came here, and I wanted to see, you know, what's changed since then and what happened. So I put together a couple of slides to kind of show, you know, where we were in January and where we are now. So one of the biggest challenges, and these aren't necessarily technical challenges, but they're organizational challenges, but they really impact the technology that we can use and how we can use it, which is a very interesting topic. So one of the problems that we had was downstream development speed. So like we developed this whole platform system with Mongo and Solar and this API, and it didn't do specifically everything that our clients wanted it to do. Meaning that our individual teams who wanted to use the search results wanted to sort and filter in very specific ways that the API didn't support. The underlying data structures supported Mongo and Solar, but the API that we exposed to them didn't. So we had a choice, right? We could either expose the underlying data store directly through some kind of DSL language or as a pass-through Mongo query or something, or we could build it into the API. But our team didn't have enough capacity to build it into the API as fast as the client teams needed it. And so the client teams started to get frustrated. They're like, we can't move, we can't move, we can't move. And so we had to sort of change our architecture a little bit in order to accommodate some short-term goals, even though the long-term goals was still to develop this sort of core platform. The other challenge we had that was when we had the UI, the facade, the API, and the data store all being run by different teams, we had a hard time identifying where a problem was. If there was a bug in the code and the users especially told us, like, this is a problem, I can't see my data, we had to go through 3 or 4 teams before we figured out where the problem was. And that was an ownership challenge, right? And then the third problem was really engineering platform choices. I didn't sort of talk about this earlier, but we have a very diverse technology stack. And we actually give our teams a lot of freedom in what platforms and technologies that they can use, as long as they host in our environment and as long as, you know, our ops team is able to handle them. You know, we wouldn't necessarily let people use crack, but But you know, if they want to use Rails or PHP or Python, we're probably okay with that. So this was kind of the architecture that we ended up with just due to necessity. And this is a terrible architecture, right? This is awful. So we had all of this source data here, and I'm saying that I designed it, so it's purely on me. So we had all this source data here, and it was going onto this bus. The message handlers were handling the data and then putting it into these Mongo buckets down here. And then it was exposing it via this API that I showed you earlier. And then this other team over here that was developing a new platform actually ran a nightly ETL job and spidered through the whole fucking API, grabbed it, and put it in their own relational database. And it was like, come on. Like, this is the whole point of not doing this, right? But they were like, no, we don't have the querying flexibility that we need, and we can't move fast enough, so we're going to do this because it's comfortable for us. And, as the architect, I said, no. And they said, well, we're going to do it anyway. So they did, and we had to sort of adjust our architectural strategy to sort of satisfy the fact that this was going to happen again and again, that we weren't going to be able to provide a core data that serviced everybody all the time. So what we ended up with was a slightly different architecture, so that instead of relying on real-time REST APIs to supply all of the front-end data, we started to really push data through the service bus and make sure that the data that was going into the service bus was actually cleansed at the source, meaning that the data that was available to all of these teams to subscribe to in sort of an SOA fashion was already clean before it got into the final bus. Meaning that if clients, this particular team was the Ruby on Rails team I mentioned earlier, if clients wanted to put their stuff in their own database, that was fine. They could do that. All we were going to ensure was that the data was clean on the bus and coming out to a point where they could grab it, right? And they wanted to have very tight control over that data, meaning that even though data was coming from all these different source databases, if that data was messy or it wasn't where they wanted it to be, they could actually stop it, right? They could see the data in sort of their administrative tier before it actually went into their front end tier. All right? So the other part of, I just want to mention one more thing about this architecture, is that the data cleansing process was actually starting to happen at the source, which really benefited our old data and our new products together, our old products and our new products at the same time. We are starting to have manual data cleansing. We actually want to have automated data cleansing that works with a data cleansing service like one that you're probably all familiar with in Century City. But our contract isn't quite signed yet, so I'm not allowed to put their logo on my slide.
So you're saying if you get this down to where you cleanse it sufficiently down there that these people won't have to store all the data, they can just access it?
No, I think they're still going to store the data, right? Because they want to have querying flexibility that we can't provide them fast enough, right? They want to have a querying platform that they're comfortable with. In the case of Rails, right, they want to host on Heroku and they want to have Postgres so that they can run their active record ORM, right? The search product that I mentioned earlier, that's still a consumer of the data of the bus, right? The bus is still publishing those messages out, and the Mongo and Solr persisters are still running. So the data is still running through that centralized process, even though it's not a real-time querying and REST API. So as I say, the image search product that I mentioned earlier is still going strong. We get about 15,000 searches a day, which if you're counting is about 20 searches per minute, so still way lower than 8,000. We are much better at Solr than we were when we started. Solr is a learning experience all the time. We've implemented some really good stemming, and plural synonyms are fantastic now. So plurals and singulars now return the same data, which for our use case is important, even though not everybody agrees that that's what you should do, but it exists and we got it, and now our users are much happier. But we still need a lot of improvements. Like our free text search for weddings is very domain specific, meaning that if you search for bouquets, you're looking for something very specific. And Solr doesn't understand our domain. So we need to have a manual sort of best bet section where it's like, we know what you're actually searching for because you're getting married, but you don't know yet. And then we just need much better relevancy tuning where we're looking at our data and we're looking at our things. So that's the big project for image search right now, is to really understand what our search algorithm is.
Now, that relevancy is tuned to the client, specific client?
I'm sorry, I'm not
Is
sure
that
what you mean by client.
The client or the category they're searching at?
No, it's going to be tuned to the term that they're searching for, not necessarily the client as a whole, but whatever search term they're using in that case.
No matter what client, they're going to get the same.
They're going to get the same results if they search for the same term, correct. MongoDB has been very stable. What the challenges that we've had with it, like I said earlier, is that people are just not very comfortable with document schemas, right? They're not very comfortable with free document schemas, and Mongo specifically has a challenge with cross-querying. So it's very good for sort of read-heavy entities and for logging where you're actually doing this stuff, but it's not very good for navigation and filtering, which are use cases that we actually have as a company a lot, where you're actually querying lists of data and showing them in a very deterministic and specific way. And then we've really had a hard time with many-to-many type of entity relationships. And I don't mean many-to-many in the sense of a relational database is many-to-many. I mean many-to-many in the sense where the actual physical modeling of the data in the world, in the physical world, is a many-to-many relationship. And the example that I give a lot is this image idea, right? So when you have a collection of images, you have both the entity that it's a part of and the image itself stands alone. So sometimes you want to query for a list of images, and sometimes you want to query for a list of entities. And so you want to be able to query both sets individually, but you also want to be able to query them together. Mongo has not been great for doing that. You have to seemingly jump through quite a bit of application hoops in order to get there. That's what a relational database is really designed for. So what we've sort of come to the conclusion of is that when you go, all the way back to the beginning slide. Sorry. That what we thought was going to happen was that these two, the Neo4j and the MongoDB and the Solr trio, was going to sort of push the relational database away. And what we found was that actually each of these things are being used for separate purposes, and that the relational data is really, really valuable for the kind of deterministic querying that we're doing. And we're really not going to go away from that. We're going to keep using that for what it's good at, but we're going to also interject Mongo for things where it's a little bit better at. So it's much more of a hybrid scenario than we were at 6 months ago. All right, well, that's all I got for you guys. 27 minutes. That's pretty good, right? 27 minutes.
So, did you find that the message bus was good for synchronizing your reads? Did you have any coherency issue across the stores and publication?
There is some eventual consistency issues, right? Like there's certainly some latency problems where different parts of our application get data at different times, and there's they don't match up. So there's some, as a developer, that's bad, right? Like as a developer, I look at that and I go, oh, that's kind of crappy. But our users don't really see that because they're using our applications somewhat independently of each other. Meaning they're not jumping from one application to another where data exists in one but not in the other. They're either using one app or they're using a different app, right? So they don't notice that the data is out of sync. The worst instance of it was where one of our advertisers had changed their image, and the image showed up in the new image showed up in one application and not in the other application, and they got very upset that the old image was still in our application. So that was the most. I'm not sure if I answered your question or not, but that was the sort of biggest cohesion emergency that we had. Sure.
Do you guys use DynamoDB and Neo4j?
We used. Did you ask if we
I saw on your slide, the page that you showed. DynamoDB and Neo4j.
Oh, yes. So we do use DynamoDB, actually, but we use it for caching. So we use Dynamo as a, like a Redis type of use case. And it worked actually very well for that. Where did you see Dynamo?
On the right there. This one right here, on the right, all the way on the right.
Oh, it's in the little words here. I'm like, Dynamo doesn't have a logo, so I was like wondering where you guys saw it. Yeah, so we do actually. We use Dynamo really for like a Redis cache. So at the time when we designed some of these applications that use it, we were very enamored with AWS's services, right? We wanted to try to use as many built-in services as possible, rather than setting up like a Redis cluster or a Memcached cluster or something like that. And so we went with Dynamo because we needed a persistent caching layer, because we were actually pushing data into a cache, right? I talked about that a little bit earlier. So because we were pushing data into the cache, we needed something persistent. We needed something with a disk backup. And Dynamo had a very fast read speed, right? And it scales very well horizontally without having to do a lot of ops work. And so obviously that's supposedly the benefit of Dynamo. But I'm not working on that team anymore. And I heard like an email like zoom by my desk that there was some talk about migrating off Dynamo and onto something else, to Mongo actually. So I don't know what the story is, like what they're frustrated by. So I need to actually go back to that team and ask them like, hey, what's wrong with Dynamo? Neo, we are using it. We've imported our favorites graph into there. So when people favorite objects within our site, we're actually doing analysis based on the graphing layer. It's in a sort of labs type of environment right now, where we haven't exposed it to any customers, but it is running and has all our data in it, and we're doing things on it.
Why graph storing in that case on favorites? How does that help?
We're looking for clustering. So some guys wanted to play around with graph databases, so they're like, hey, I can do clustering in this, so they did that. We're looking for favorites clustering to understand why people are drawn to certain types of content versus other types of content.
You guys also use any recommendation engine or any?
That's a really good question. If you want to get more into that, we are looking for recommendation engine engineers.
Can you repeat the question?
Oh, sorry. He asked if we're using any recommendation engines right now. So yeah, in Austin, we're actually looking for people. So if you want to move to Austin and you're into recommendation engines, do let me know. We are evaluating several. There's 2 different use cases that we're looking for recommendation engines right now. So one use case has to do with a generalized recommendation system, where you can actually put in sort of whatever free text data content, like a full article text, and it actually does recommendations based on that. And then one is a more deterministic recommendation engine, where you have very discrete inputs, and then it comes up with very discrete outputs. So I would say one is loose and one is really tight. And for the tight one, we're looking at Fredhopper, although we're not thrilled with the amount of configuration you have to do. And we're looking at a couple of other ones that are in stealth startup mode, actually. And then on the free recommendation side, they want to use Mahout.
They haven't started, so you guys.
The what?
Mahout.
Mahout.
You guys haven't started yet.
We have not done anything on Mahout yet. I think there is some proof of concepts going on, but to be honest, we've had a rough couple of months in terms of getting stuff out the door, so some of those lab projects kind of slowed down. Anything else? All right. Thank you guys very much.